Okay, today we will review what is the slightly linked list. Why I want to review it is basically because linked lists are this kind of data structure that even though we don't use it plenty times into the reality, uh, still in this case very useful when we are solving exercise. And aside of that, slightly linked lists give you the entrance to more complex data structure. For example, trees are or graph or yeah, mostly tree and graph are the one that is giving you the entrance. Tree, graph, traits that are given to you. If we go to the data structure, we can just see the images, and here we have it, right? We have basically linked lists, trees, and graphs. Those are the ones that they are connected. When you learn these linked lists, then you start understanding what are a tree and what is a graph in this case. The majority of time we have the arrays, the stack as queues, that are the arrays, we know it. The stacks, very interesting part is in JavaScript, stack and queues are basically the same. That there are the arrays, the normal one. The stack is you push at the beginning, but you pop at the end. And in this case, in the queue is the queue is you push at the end, you remove at the beginning. That is the only difference that you have it. Stack, you push at the beginning, you pop at the beginning. In queue, you push at the end, you remove at the beginning. But basically, they are the same um, the same array that we have it. The one that is changing is the linked list. The linked list, basically, I would like to go here, is this data structure. The linked list contain a head, contain a head, and inside a head contain a node. This node is an element that contains two elements. One is the data, and the other one is something called next. This next is the connector to the next node. In this case, you have next data and next. This next connect to another node. In JavaScript, in this case, because we don't have much, we just have here the head, we have the value, and then that is connected basically. That is what we have. It's a node. The node contains data. It doesn't really matter what you are having over there. It's just data, right? Could be a number, could be an string, could be another array, could be, if we're another linked list, then it would be more complex that we have it. And the address, or in this case, next. This one is connecting us to the next element that we have it here. Okay. Basically, that is what we have. Next, data, and next, data, and next, data, and next, data, and next. And the last one is connecting to null. That in that way we know that the data structure finish. In this case, this type of data structure doesn't have a limit that we're saying. It can be as bigger as we want it. And here we have the data structure. In JavaScript, as you were saying, we can represent it very simple. For example, linked cons, linked list. And this linked list usually have a head and that head start with null. This head, that is the beginning, we can just have it. For example, linked list dot head, and this one can connect to a node. And what is a node? Node is data. Here you can have a piece, a piece, a piece of data and another connector. Then in this case, could be, and as we are seeing here, is the next, right? Or the address, as you wanted to see it. Yeah, we have the next. And the next, if it's the last element, finishing null. If we connected that one, we can just say linked list dot head dot next. That element can connect to another piece of data. This can be anything, can be a number. And the next one, we have just next one. If we see, in this case, our linked list, I have represented as simple as I can, linked list, and we run it, we have this element. It's a head with a data, with the next that is connected to the next element. That is what we have it. That is the representation that we have here. Yes.
So if we have, for example, really big nested linked list and you want to reach the last one, you just use the recursion and add something at the end, right?
Exactly.
Mm. If it's null, then any.
Add something.
Mm.
That is how the majority of time you do it. You record, you go till the end. And how you go
But
till the end?
uh, why we need so painful data structure like nested?
Okay. The first thing is uh, this one is just the beginning of more complex data structure. That is just the
Mm.
beginning. The second option is very memory efficient in this case. When I say very memory efficient, it's like you don't have the limitation that they have to be in one just part of the array. Let me show you something. Let's
Okay.
see that I want to add something at the beginning of this linked list. To add to the beginning of the linked list tend to be not that easy because first one I had to say, for example, I can say let linked list link linked reference. This linked to the reference will just save the information that I have in linked list dot head dot next. I am just saving this point. Then in this case is head. Uh, I am just saving what is in the head. Okay. Now what I do? Now that I have it, this head is what you are bringing here, is the data that we have it. Then I can add something into the linked list dot head, and I can add something extra. For example, I can add data. This is new data at the beginning, and I can say next will be equals to linked reference. And I will close this one. And if I do it well, next. Oh, I'm sorry, here I need a comma. And it doesn't have to be this one, it has to be. And then we have here head, data, new data at the beginning, next piece of data, and next, and next, and next. What is happening? Imagine that you have a lot of information in this linked list, as you were mentioned, David. To add this information, I just create a reference and then I added my data. This one is basically constant time. This is constant time. If you want to add at the beginning in an array, in this case, it will be big O of n. Then it's more efficient adding at the beginning of the linked list. And removing from the beginning is also more efficient. And aside of that, you can create also a reference to the end and give you big O of 1 to add and to remove. Is efficient to add and to remove, is very inefficient in searching, is very inefficient in this case in adding in the middle, but it's also give you some, it's a little bit more efficient than one array.
But can you please explain like your code right now? So you create the reference one,
Mm-hmm.
and you put your linked list that has in your reference, and then you created the data. And so what's they doing on line 20? You put the like reference there.
Yes,
The
just
whole new like the whole data. I mean the linked list. You just okay. Uh, uh, so you created at the beginning for it right now,
mm-hmm.
right?
Yes, all the
Oh.
information that I get created at the beginning from here. These two are this reference, and that is what I am
Mm,
adding here.
okay, I got it now.
Mm-hmm. I say, and basically this is like a linked list. A linked list is one object. This object has a head. That is the way that is designed. The linked list in this case that has a head get the null at the beginning, and the next is connected to another object. And the next object has the same shape, that is data annex. Something that you will find the majority of the time that this is called value or val. Then, but it will be basically the same. It's just
Yeah.
how some people are naming it. The
So
majority of the time.
right now I like have the picture, but I mean I understand it, but so you saying it's better to add at the beginning than rather than like to the end, or is like more efficient? You saying like
More
which
efficient.
that is like then adding to the end of the linked list, right?
At the
Compare, I mean.
beginning, how I design it right now? Yes.
Mm.
How is in this moment designed? Yes. But you can, in this case, keep track of the last element. For example, you could keep it like a, for example, let tail, and the tail will be equals to, for example, I keep track of this one. And every time that, for example, here, I can say tail will be equal to what? Because I added something, I can just say tail dot next. And this one is the end. And then one, I can say, for example, if I just say this tail here, if I just see this tail, right now I have it undefined. Wait, let me see. Tail linked list. Then I have here the head. Then I will be see here the head. Tail does next. No, that is what I have here. Tail, head, next. We have here null. Or if I just have here sol dot head, then I have here. Everything here is just a reference, David. I can create reference to the beginning or to the end. Now, if I want to add to the end, then I can just say tail dot next, and that is the end of my element. For example, I can just,
Can you scroll up? I'm just confused, kinda. So we have created linked list. We have a null. Then we created the tail. Okay, linked list that head it's equals to that was null before, right? Now it's this one.
yes. Mm-hmm.
And we are saying tail is tails dot head. Is which
Mm-hmm.
one? Is this linked list? That linked list is equals to tail dot head is equals to what?
Volume next.
The equal to this one.
But equals to this one.
Mm-hmm. What is this? The most important part here is what is passing by reference and what is passing by value. When I
This
make
is
this tail
reference.
equal to linked list, I am creating a reference to this element.
Yes.
And
Then
then,
So, sorry.
changing linked list dot head.
mm-hmm,
And if you do tail equals to tail dot head, it's gonna be equals to the to this two. And then tail linked list dot head dot next.
No.
This will change to our next now, right?
mm-hmm.
And linked list reference, linked list dot head. Oh my god, I'm confused. Can you
But
can you clear your history and run one more time? I just wanna understand. In new data. But why that linked list that head is not changing in line? It's not the reference, the line 22.
This one,
This one is reference, right?
that one is a new reference. It's a reference to the head. That it will be this one. And then that one, change it to the new data information that you have here.
in line 24, not adding the new data to the beginning of like linked list.
Sorry, I cannot hear you clearly.
I'm saying in line 24, he creating the new data to the beginning of linked list.
Let me try to do it in a different way. Okay.
I mean, like, I just maybe if you can explain step by step.
Okay.
Yep.
This one, it was extra just because I wanted to show the difference between having a reference into an element and let me see. I don't need this one. Okay. A
This one I
linked.
understand.
Okay, then we can keep it like this. This another part was basically because David was asking me, but at the end is also is more complex to add it at the end. And I say, yes and not. Yes, if I had to go every element till the end, it's more expensive, but I can create a reference to the end of the linked list at the beginning. Then I can keep that reference for me and use it. I can have a reference to the head and I can have a reference to the tail and just keep track of those two elements. But
So,
we can.
quick question. For example, all of these things are here, right?
Exactly.
All of the things are this one.
Exactly.
And when you create the linked list, this whole of the thing, actually this one.
No, no. This one that you have here, just to go here. This one that I have here, get the reference from here. That it will be all this part. And what I do right now is head this part, I put it here, and this one is the connection to this one.
But how it's happened that naming are same? For example, line 17, linked list that head. I thought this one is gonna be the representative of this one.
You are right. Yeah. Yeah. Yep. This is the representative of this one because here I already removed it. This null got removed. Yes, you are right.
I expect that this one is gonna change this one. The replace.
Yes, this is correct. No, this is correct what you are seeing. It was my mistake here because I am trying to represent this since the beginning, but makes sense what you are saying. This one get connected here, and then all of this data that you have here is stored into the reference, and then the reference get connected here.
It's actually the temporary. We can say this one was a temporary storage.
Just to not to lose the data.
Yeah, that data what we have above. And actually this one, the value is changing about this one. And this null is becoming this one, right?
Exactly.
Like this. But
exactly.
since linked reference, the holding all of these things, we have it now, the all of them. I understand it.
Okay, thank you.
But I have a question.
Yes.
So we can create the new data to the beginning, we can create at the end. Like, so what about the middle since we have only values?
That is problematic. If you want to find in the middle, you have to or go from the beginning till the end or the end to the beginning. But in the middle, is imagine right now that a linked list is like a cable connected one element to another element. If you want to go to the middle, you have to move into that element.
I mean, only maybe the only one is possible, but you have to know what is in that data somewhere in the middle. Like you have to know what is inside the data, so we can compare
No,
with something.
yeah. You have to know what you are looking for example, and this is when it's arriving the how can I say the funny part of this one. Let's say like you are looking for something here,
Yeah,
then
at
I
least you
can,
have to know something to compare with something, like to reach it, right?
yeah, you will have to, and the majority of time, you have to create temporarily in order to not to lose the data. Like if I can say like a temp head, and this is something all the time will be equals to linked list. And you all, this is just creating a reference. The majority of the time you will go to then you use while, for example, while, and you have to look for something while temp head dot next exists, and for example, and let's say it,
You forget to
uh,
put to line 25 linked list dot head. So right now we don't know
linked
what is
list
next.
dot, okay, yeah, linked list dot head, perfect, thank you. And
Mhm.
here, in this case, we can just do it like let search element equal, and here I will just say null. Okay, and here I can say search element, and this one has to be, in this case, null, not null, and
Mm.
you go and start searching here something. Then you are in the head, then you say if, and you have to know what you are looking for. Let's say like I
Right.
am looking for the 25, and you say is temp head heap dot val equal to what you are looking for. Let's say like at the 25, then uh, in this case, you just say search element equals to temp head, and then you have it here.
Then
And if
have that
you,
one.
no, because I want the whole component. Usually you want the whole head.
Or
Then
what
I
if
want, huh?
you have next over the?
Then
It's fine.
you will bring the element with the next, and that is the idea that you take the node, the complete information. But you can just get the next, and depending what you want to do, and then you can just go console.log search element, and if everything is correct,
Mhm.
I have to have here a node, and that is
We can
sorry.
select the linked list.
Uh-huh. Console log. Uh-huh.
Do we need to return something? No.
No, because it is just an element. Here,
Yeah.
let me just see.
It just didn't show up.
It's still running.
It's still running. It's because of this one. Is my search is yeah. Okay. I think it would be or. Okay. Uh-huh. Okay. Temp head. Would you know why? Because I never say this temp head. It will be a temp head dot next. Because this temp head to temp head next is the one that is created since the beginning. Because right now I say temp head, then I have this one, and I check temp head val equal to 25. No, then I have to move temp head to the next one, and the temp head will arrive here. This
Which one
one,
is the next one? Which one is gonna be null, right? Oh no, it's next one is gonna be the value 25.
exactly. But because I move it, it will just change a little bit. Then here at the very end, we have here next. Oh, I have to just say else. If not, we will not have it here. Mhm. It's saying null, but search element null.
Supposed to be supposed
Yeah,
to
it's supposed to be here, right?
be. Okay.
Uh-huh. Temp head. So I am here. I think it's never happening over there.
It's not,
Temp
it
head.
looks like not recursion, maybe we need to go in.
No, no, because this one it will be similar. We have temp head equal next. Is passing here. Okay.
While temp hip.
Here, this one has to look, it's happening here 2 times. Now, let's go and see. Temp head. I think we don't have to see this one. And there we have it.
No.
What did it?
I just removed dot head. This one was the problem.
So it was going to the next one.
It was not checking the last one because it's
Yeah.
saying like temp head next. It was saying temp head next. It was null. That it was this one. And I said, oh, temp head is null. Then was never checking the last one. And if I say if temp head exists, that is this case, temp head exists, then just check if the element is here. And then it's just giving me the last element that I wanted. If I want to look for something else, I can look, for example, for this one that I want.
This one is the first one, right?
This one is the first one. It's supposed to give me a big, it's the second one. This one is the first one right now.
Oh yeah, we changed it.
This is the beginning.
You forget and word. I mean, to the beginning. New, not here.
Okay, new name. Then there you have.
So, for example, if someone asks you, oh, find in that data, like something which you don't know, it's impossible, right? To go to the middle of the data and searching. Okay.
You don't even know how long is that thing. You
Yeah.
can have like a first, if you want to go to the hub, you will have to do a couple of things. Like for example, iterate one by one and count it. Okay, I have 35. Then I will go to the middle. It's not efficient.
Cancel lock it, and in cancel just open the whole data.
It's a headache. Then if you compare this linked list, what do you think it will see in the real life? Is something like a chain, right? Like a yeah, like a chain, like a something like this that you have. Basically, you don't know how long it is. You are just adding a new element, 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 and this thing can be infinite. The plus that we have with this one is like the array. You have this when you add to the beginning, you have to change all the indexes. In this case, you don't have to do it. And that is a very big advantage that we have it.
Mario, so the linked list is always start with the object inside of object, or it might be array which inside gonna be a lot of nested objects?
What you are telling me, that is called a try. Yeah, is this one.
Which is just started with the array, but is going nested objects, right?
Yes, it's going a nested object. Is something like this, that you have some at the beginning you have it, and then you are just doing it. But There is something that is called there is something that is called a hash map plus a tree and you create something like this, right? This one, building a trie and a hash map that you have it. It is a very complex data structure. I have seen it, but it's not common.
What is that hash map? I
That
like
hash
often heard about this word hash map. No idea what's it.
Okay, no. Basically, a hash map is just an object. When you are talking about hash map, you need two elements. Cons hash hash map. Hash map has two elements that we have. The thing is like the hash map in other kind of when they get very big, you need one hash function. Cons hash function. Hash function. You need a hash function. This hash function return you a key. And this key, you look at inside your hash map. For example, let's say it. Here you have some numbers. You have one, and you have some information. Then you have here two, and you have some information. What is doing the hash map is here you pass some value. But here create an operation. And here can return you an element from your hash map. It's this one. You need to have a hash function and you need to have a hash map. But the hash map is basically just an object that has different buckets. In this case, these buckets are the property. And the hash function is you pass a value and create some operation, your hash function, and at the very end, return you one of these. Could be one, could be two in this case. And then you can do the operation that you needed into those elements. These kind of things, yes, are helping, not mostly in computer science, but there are something that is called load balance. Load balancers or load balancing. That they are doing this one. If you see it, you have the information, you enter the information into that function, and that function distributes you into different other elements that you have it. That it will be your hash map. But in JavaScript, blessing or not, this hash map is just a simple object. It is more similar to what we were using into frequency counter, right? Frequency counter is using a hash map. It's using, in this case, your key is used in order to access some information inside your storage, that it will be the object that you have it. If we just, for example, if we just say hash map here, you will see it. That is like this. It can be more complex, but you have it here. Look, you have the keys, you have the keys. They are buckets, and the bucket has information. And in JavaScript, you have your buckets are this one, and the information is here. I mean, it is a hash map is perfectly represented in JavaScript with an object that you use to storage information. That is basically a hash map, in other words. You have it here. You have the keys. You have the keys. Into the keys, you have the buckets, and you have the entries or the information that you have over there. If you say hash map JavaScript, then they are basically just going here. Pushing fade data, clear data on. There you have it. New map, and you are having the information. They are already doing over there. If you see this map, it's basically our array that we are adding it. There are JavaScript hash table. We don't have it here much, but here we have. They are trying to represent it, but basically they could be an array or can be an object, how you want it to represent it. In my personal opinion, I think it's better to use just an object. That is why a hash map is not something that you teach when you are teaching JavaScript, because they are basically just an object that you use with some keys to access the information inside. I don't know if that makes sense, Maxat. What I
Yeah,
under-
I got you. I
yeah,
got you.
yeah, and that is what we have it. Okay. Now that we have all of these blah 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 that we are having, let's start with the exercise. First of all, remember, one of the most common exercise that we will have related with linked list. Let me see if okay. First of all, remember that everything that you have been studying so far is still valuable. I mean, like, not because we are talking about linked list, you cannot store information or do stuff here. This is the first one. Exercise. I selected the 4 more common linked list exercise where I can show you 2 or 3 different techniques in order to manipulate the linked list. And here we have the first one. The first one is reverse a linked list. Why do I need to reverse a linked list? That is stupid. I'm sorry. I don't make the exercises. It's like a more common. The idea of this exercise is reverse a linked list is just know that you understand the concept of basically iterating the linked list, storage the information somewhere, and then iterate it again. That is one way that we can do it. Another way that you can do it is add to the end. You can create a new linked list and just start adding to the end. Starting to it as your one that you do it. I would like you to think how you will solve this problem. First of all, remember
Sort. I'm kidding. I'm kidding.
this one.
No, I see the example one, input and output.
It
That's
looks
why
like
I'm
just an
kidding.
array. Just array,
Just
Yeah.
array.
which you can sort it or reverse it.
You cannot. Okay, let me just.
I'm kidding.
Okay, let's say cause head, con second head. If that thing is working, I will just stop doing this one. Head dot sort like this, right?
BA
Just, I mean, no, just reverse.
or reverse. It doesn't matter. Yeah, I guess both gonna do the same.
But wait,
Like this.
why you put head dot? Oh yeah,
I am just making a copy. Just to
we're using reverse for the array, right? I already forget.
okay. I don't even know. I think that is not possible. If this thing is working, no, it doesn't exist.
Sort
Why it doesn't?
Okay.
I
B
already
minus A.
Reverse array JavaScript. Okay. Yes, it's reverse. that is an array. But my dear friend, this one is not an array. It's a
What is
linked
that?
list.
What do you mean linked list? It's kind of a different kind of prototype.
It's absolutely, look, here you have it. It's a linked list that it has value and next. They are representing here this one. But let me just say that if I cannot say here, like for example, you can say console log, right? You can say console log head. And if I console log this one, it will show me here some information. Look, here it is, shootout. And if I say head dot
That's well. Next.
okay, dot next, in this case, okay. Let's say like it was a head dot head.
You don't have a head, I guess.
Okay, I am doing it correctly, right? Head dot head. Dot next.
You
put
have a
head.
typo. You have a typo. He had.
Blah, blah, blah.
Yeah, give you error. Anyway.
It looks like
No,
just
no.
array, no?
Mm-hmm.
Can you
Okay.
show the example 2?
Yeah, here you have.
Same thing, array.
I don't know.
Then why
Let me just see what I have here in the head. Because no, it's not an array, it's a linked list. Okay, here we have an array that we have it here.
Can you check type of maybe?
Okay, yes. Type of.
It's gonna be object. Yeah.
Just saying undefined.
No, that console object.
Here is saying undefined.
It's output. Check the console log.
Ah, yeah, it's an object, yeah. Okay, now let's say okay, cons copy. I will make something like this, like cons copy will be equal to head, and then I will say copy. We will make it let in order to have let, and then I will say copy would equal to copy dot next. Okay, and here I will just see copy. This one has to give me something extra. Copy dot next. Why? This one has to be okay. Okay, let me see. TypeScript. Do I have it something here? Let copy.
This one looks like, look at the head.
Uh-huh.
This one looks like the, what you said. Linked list.
Yeah. This one is here. Okay. Copy equal copy dot next. Why this thing is?
Did you console log or you don't need?
No, I just wanted to return. Okay. Return copy. Okay, returning copy. Okay, why this thing is telling me that but I am using next.
This list node has a class, right? Which has
Yeah.
a value. Then you have to do head dot list node
Mm. No,
or
you
no.
suppose no, because here I am taking this copy, and this copy is just taking next, and then it's returning copy, and it's saying that copy doesn't exist. Mhm.
Check the value maybe. Copy that value.
Uh-huh. Val, right? Val.
Wow, yes.
Uh-huh. Number, okay. So I will just return head here.
You have a typo.
Yeah. You have
Subscribe.
to run. Subscribe, pay. Number is not accessible to a list node. Okay.
Ah,
Okay, now it's over there.
If it's not array, if it's not linked list, what is
Uh-huh.
it?
No, it has to be a linked list. It's not an array. I am sure that this is not an array.
But if we cannot reach the next involve, how can that solve this problem?
Yeah. Cannot read the properties of null. It's saying that this is null, but it's not null. The head is a list node. It's arriving here. It's arriving over there. But
can you switch to the JavaScript or you want to use TypeScript?
no, just more. Okay. Let's say that I want to do this. Let me just say it. If head doesn't exist, right? It's head
You put
return.
two marks.
Okay, if doesn't exist, return head. Now I am saying if doesn't exist, let copy equals to head. Now we suppose that exists. Head. I have just two examples, right? And example 3, we don't have anything. The example 3 is the one that it was giving that problem. Look.
No, we
the
actually was checking the example 1 and 2. We even didn't open the case 3.
No, because, okay, let me just try to go over here. Let's say head equals, then I will say copy equal copy dot next. Dot next. And this case, copy dot next in let me, if there is not head that is arriving here, it's not head, return head, right? There it is. If not, return copy, and I will just say console.log copy. And this one has to show me something. At least error doesn't have to show. There it is. Look. Here we have. This is the first element. The second element is showing me the second element, and the third case doesn't have anything. The problem was basically this one. And because we have this element that doesn't have anything, then when I try to go to copy dot next, this is failing. Then this one is failing.
So it means like each number, it's next.
Is next.
What if you do, look at this, can you show the output, the case one? It's
Yes, here
number
it is.
one, it doesn't exist. So if you do copy next, gonna be 3, 4, 5.
Yes, but it will fail the second one. Because I have here just two. If I hold those dot next,
It's gonna be undefined.
it will be undefined. Okay, let's go, Jose. Here you have it, 3, 4, 5, and the
It's-
next one that doesn't have anything, it will be null. It's not saying undefined, it's giving null. And the last one is just bringing this one.
Each number is a next, okay.
If number is the next.
Let's solve it then. Easy.
Easy peasy.
I'm kidding. No idea how to do it. You okay. You are suggesting start from the end to the end. We need to start from the 5.
Not needed. How you
Okay.
usually, the idea of the array is not bad.
I mean, can we use it how we doing usually with the array, for example? If the next one is greater than the previous one?
No. He is saying reverse. He's not talking about, in this case, bigger or smaller. How they are, you just give it back. For example, if you have here 2.
No, I'm talking about the logic. You just want us to reverse the whole linked list, right?
Yeah.
So that's what I'm saying. For example, if the next it's a greater than the previous one, then just move it to the forward, to the beginning. And then checking again. If the next it's a greater than the previous one, then move it to the beginning and till the end. That's what I'm talking about.
No, because the greater, that is not going to work because it's not about which is greater. It's just I want, for example, the 6 go to the beginning, then 9 go to the next one.
In this case, right? Because I just saw into the output.
Example.
You just sorted once, so
Yeah, but it's
Mario,
nothing to do with sorter.
right.
we need to return again the same linked reverse list, right? I mean, like
Yes,
it's
exactly.
supposed to be linked list, but reversed.
Exactly.
So what I see is like we have head, inside of head we have value, for example 1, and next. Next we have again value 2, and next value 3, next value 4, next.
Two things.
We need
Two
to
things.
recursion 100%.
Two recursion. Yes, correct. We need
Yes.
two. Yeah, correct.
We need 2 recursions, but one.
You basically solve it.
But I don't know how to implement. I don't know how to.
Okay. Tell me what will do the first recursion.
First recursion, we'll find the first one, the beginning one.
The beginning, you already have it. You don't need to find it.
Okay, last one.
How are you gonna find the last one?
Okay, let me ask you something. The ideas, they don't change. How you will reverse an array without using reverse?
Sort.
No. Sort is different. Sort, just put it in line. But here is, I think what you don't think that it is 1, 2, 3, 4, 5. Think about that they are 1, 20, whatever.
Yeah, I will follow from the last one, like from the end. Follow from the end and put it everything to my result.
Oh, Or we can do what? For example, if we take the just simple array,
Mhm.
we remove it from the end and put it to the beginning. We remove it from the end and put it to the beginning.
Okay, well, you remove it from the end and put it at the beginning. But we cannot do that into the linked list because I cannot go to the end. I don't have access to the end. But maybe we can inverse what you are saying.
Do what? Inverse?
You can
What
make
does
it
mean?
bad. Yeah. But you are saying take to the end, take to
Yeah,
the end and put at the beginning. How
yes.
we can do that backwards? Take to the beginning,
Oh, the first one to put it to the end. Okay.
the first one, put it to the end.
Mm. What like
Hmm.
this? Doesn't.
There are different ways to do it. Okay, first thing, let me go with this one. Even I will give you the naive way, and I would like maybe you can keep it and try to do it another way. Let's say it that you have one const that is data. This
Mhm.
data is an array. I am just saving the information into the array. You're saying it. Do you remember that we were doing something like, okay, let's make this copy head equal to head. Okay, I have this information here. Now I will say while copy or while copy head. Now, the only thing that I do, I am iterating this array, right? I am iterating.
Mhm.
Then I just say copy head equals to copy. This is the complicated dot next. Okay, but before that, in data, I can say data dot push copy head.
Okay, now I understand the way it's. I got it here. I got it. But if this is gonna be, I'm gonna start to complain. If you're gonna return at the end our data, because you're gonna return just array, not the.
Do you remember that Maxat say two recursions?
We'll see. Okay, because right now you just do it like, okay, you already reverse it because you already like copy head, keep going to the next, and the data keep pushing it to the itself. But
Okay,
right now we have
now,
only the. Okay.
okay, I run it all there. This is quite inefficient what I am doing. I am recording
Yeah.
all the linked list.
Right.
I don't
The
understand
sec.
what you're doing, to be honest.
Okay.
You created the copy of her head. It's not the copy, it's reference. You created the
Yes.
reference to the head. And you are saying, while this one exists, you take it and push it the first value. It's number one, let's say. And then you are saying copy head equals to copy head dot next. It's gonna be the next array 2, 3, 4, 5. Right? 2, 3, 4,
Okay.
5.
Let's say.
Oh no, it's gonna be
Right.
just 2. It's gonna be just 2.
2 and next, because remember that this is next. Next, what is doing is arriving to next, and next in this case has another value.
It's 2.
Remember what is 2 with another next.
With another next, yes.
Then it's arriving, and here I just taking the value. Let's say it. If I have
Okay.
here,
The question is, when is gonna stop?
when copy head is next undefined.
No.
Null or null.
Null or undefined?
No.
Null. For the here they are using null.
How that if copy head that next gonna be null, it makes false, right? That's why you're gonna stop.
Exactly, because this copy head, then it will be copy head will be inexistent, or it will be null, then it's a false value, Y false, then don't do anything and go out.
For right now, we just create the array which have all values from the head.
Exactly.
Just push it in our array.
Or let me just console.log and I will just say data. This is just the array. Look, 1, 2, 3, 4, 5. It's just I was just iterated. They look a little bit different. I take the value and put it at the value and put it at. This is like a 1, 2, 3, 4, 5. These are just values. If, for example, if I say data 0, this is an array. Then in this, I just have the 1. So this is not next.
One thing before you go to continue, just can you do one thing? I just want to make sure it's not gonna work. Can you put no remove the console.
Data.reverse you wanna do?
Yeah, can you return data.reverse? I just wanna curious, is it gonna work?
Okay. Result.
No,
okay.
still
No,
okay.
you need a list node.
Okay.
Expected
make
return
sure.
type link list node, yeah.
Just make
Yeah. Okay. Why not, right?
yeah.
Okay. Now, here I am just using this one as a support. Let me just create let second head. And this second head will be equals to head. Okay. Again, right? To the head. This is the second for loop. But you know what I will be doing? I will just say it. While second head, there, what do we have it over here? I will say second head of val will be equal to something. What do you think if I say data dot pop? From
Hope
where I
will
am taking.
Hope will take the first one.
Last one, pop.
Oh yeah, it's shift not shift first one. Yeah.
Yeah. Then I am taking the last one and I am put it on the beginning.
But wait, you are saying value, and why you're putting inside of that object? Well, yeah,
Yeah.
It's
This one,
supposed
right?
no, it's supposed to be the double dots. It's object, right?
Double dots. It's gonna be inside.
Oh no, it's not object. Sorry. It's not object.
Yeah.
My bad.
And here I just say, and this one is what to make weird, right? Because what I am doing is.
And you will return second hand.
No, I will return. No, I will return head.
Why head?
Because he mutated the head.
Because it's reference. That's why.
Yes, because this one is a
second
reference.
head and head are gonna have the same output.
Since he didn't use any shallow or deep copy, he just mutated to the original.
Just can you return the second hand? I just want to see what's gonna happen.
No, this one will be undefined.
It's since why? It's reference, no?
It's a reference, but right now it's in the last position. Because remember that what this reference is always moving to the next,
Yeah. Exactly. I forget that it's moving.
Yeah, and because it's moving at the very end, you finish in. Oh, there is nothing over here.
I don't understand the topic at all, to be honest.
I understand it, but one thing, Mario, just make sure line 26 data.pop. When we're using the data.pop, it's supposed to be give us all values, but not the last one. Right now, you somehow get the last one.
No, pop is just giving you the last one.
You're right?
Yeah.
Just make sure.
Yeah. What do you think is what is arresting? In the previous array is just keeping it that one.
Wait.
Yeah.
Wait. I have a question. For example, you are
Yes.
saying in line 17, we have a head. We are making
Mm-hmm.
a reference for that head, right? And we are working with that reference. So it means
Mm-hmm.
that the initial head is not changing.
Right now, not the original head is just over there.
Why?
Stay.
Because it's not the copy, it's actually the just reference.
Yeah, but here I am not doing anything with this. I am just taking the value. I am
You-
just copying the value, and because the value is just a number, then I can just copy
Oh, you are
by.
just copying the value. Oh, it means even actually your copy head and the head are same now, right? Then actually you don't need to even create the second copy head. You
Exactly.
can
I
you
don't
can
need.
all you can only work with the head itself directly.
Oh, now I got it. Okay.
It's possible. Yes, it's possible. Actually, you can even create a new one, something. But I will leave you to that headache because
No, don't leave, please. I'm not gonna sleep today then.
So, if you
okay, there it is.
so
Beats 100%.
Mario,
Uh-huh.
just to remind ourselves, so if you just create the array and make it array that pop, like it is gonna be the whole values, but only the last one gonna remove. But if you create a new like for a variable and make it equal to that array that pop is just gonna give you the last one, okay, right?
Exactly. Let me
Okay. I just
just
already make sure.
okay, and I will give it. Let's say it. The just let's make it cons array
I sent you,
equal.
you can go to the
Oh, yes, thank you so much. You are
yeah,
so cool.
save your
There are
time.
two. Yeah, thank you. Okay, two things. What you will have here
Gonna
and
be
what you will have in the letter A. These are two
A
things.
gonna have the last one, the array gonna have the whole except 6, I guess.
yeah.
Exactly.
That's where I get a little bit confused. I already forget how it works.
Yeah, it's like this.
Yeah.
That is correct. Okay.
Can you please one more time go back to that? Yes, can
Yes.
you scroll down a little bit? So actually, you are just taking every number and put to your data. In second hand, you
Mm-hmm.
again make a not deep, the shallow copy of your head, and then saying, well, second head is exist, it's not the null next. Then
Mm-hmm.
the second head that value you are changing, right? You are changing, reassigning to data that pop. Now it's a 5. Instead of 1, gonna 5. Then go to the next. Instead of 2, it's gonna be 4. And go. But you are returning head. Since
Yes.
you are returning head, since you are reassigning the value, and that in head is also changing.
Exactly.
Since it's not
Limited.
a deep copy, it's just the reference. Mhm.
Exactly. At the very end, everything. I am just changing head. Head is the one that is changing. I didn't create anything. Everything that I had been playing had been just um in this case the head. Okay, but
So
here is
the mutate our initial value is not always bad thing.
and okay, I will tell you, it's very bad.
That's what Mario teaches. I'm gonna tell somebody. Mario teaches.
Never say that. Okay, in this specific case, when you are working with a linked list, and I
I'm
mean, there
kidding,
is not
Mario.
another way.
Yeah.
Okay, you will say, Mario say never mutate the data, but Mario also say mutate the data, right?
Yeah.
Mario, can you please try one thing? Instead of while
Yes.
copy head, just put head. No, not here, not
Oh,
here. In the first
here.
place, just head, yes.
Ah,
Data
okay.
dot push head, yes,
Uh-huh.
and head, yes, and delete that line 17.
Like
Is it
this?
gonna work? No, delete line 17. No, right. Here is head, and line 17. 17.
Here. Ah, it's
No,
1-7.
17.
Uh-huh.
Yeah, delete this one. The whole thing, the whole line. No, you don't need this line. Yeah.
Delete.
Can
Okay.
you try like this?
Suppose that doesn't have to work, but let's go.
You are saying that
Because
you are not changing, but
yes, no, I'm not changing. Okay, here you are changing something. Look, you are saying head, go to the next one. Then head is losing that element that it was before. You are replacing it here. The head is one element, right? That you have it here. Let's say like you have connected two elements. You have connected two elements. Okay. This is one element, this is the second one. When you're in right now, head is pointing to this element. Now head, you move it to this one. What happened with this one is go to the garbage collector.
but how when you are using just the reference, it's not happening. It's not changing the
Yeah,
whole.
because the reference work out okay.
I hate the
Uh,
references and the shallow
is
copying, deep copying.
yeah,
It was
yeah,
confusing.
yeah. Let's say that this and okay. Let's say that this one is my linked list. This is my linked list. This is my linked list. This is my head. My head is pointing to one element. The head is pointing there. Then I create the copy. The first copy. The first copy was pointing at the same place. Then what I am doing is the head is still over there. What I am moving is not the head. What I am moving is the copy. The reference of the copy to another element, the reference of the copy to another element, the reference to the copy to another element. But the head is still pointing to the first place, right? What I do is like the road is there. I am just walking the road, but with the reference. My first
But
reference getting, I didn't move it.
the time when you want to reassign that number, it's changing. Like how it happens.
Here is happening. Here is happening. This is the road, right? This is the road. I create the second reference. The second reference. Then when I enter with the second element, I modify this and I move to the next one. I modify this and move to the next one. I modify this and move to the next one and I modify it. This one, the head is still pointing to the same place, but the object itself, it was changed. What is the information inside? But if you see it, they still stay in the same memory space.
Can you please go one more time to the lead code?
Yes,
That part you are
absolutely.
changing the value,
It's
reassigning
this one.
second hand. You are using second hand, not head. Oh.
Yeah. And this one, let's work with a simple object. Just because con head, let's say a student equals something, right? And he will have name. And here is Jose, because there is no more. No. Now I say cons reference, and this reference is equal to a student.
Mhm.
Now I make a reference dot name equals Tomaso.
Actually,
Now
it's supposed to change, right? If you console.log student.name, it's supposed to be Tomasa.
Exactly.
This one is easy to understand, but
But the idea is the same. Because the only thing is the other is a nested object in object. Now let's say like you don't let's then let's say like we have here grade, and this grade is an object, and it say mate, for example, mate, and it's 5. Then if you write this reference and I go, for example, to grade
names
to
dot
math.
grades, I guess it's
No, this one doesn't have to be here. Math equals to 8. And if I go in this case and make the student,
it's not gonna change it.
why not?
Why, yes. Okay.
It will going to change it because this one, what is happening here?
I understand it. Yeah.
Yeah.
But no, here it's fine. I'm just still confusing about that assignment. Can you show the example with like kind of with assignment? Can you go to the just linked list for me?
Yes, absolutely.
So, okay, I understand it. When you are changing the value is also changing over the in head. But when you use just head dot next, we are losing that first head value. But if you create a copy of that head, like copy head, and we are moving, okay, I understand. Thank you.
I feel like okay. The book, I
Yeah, I
lost
will
you.
understand
We
it.
are.
I can even explain it.
Oof, that's great because I will give you another exercise right now. Okay, David, still there?
Yeah.
Okay. Okay. Then I will give you the second exercise. Okay. Let me just. Okay. This one, by the way, is require less code, just a little bit more thinking. But the code is very short.
Middle of the linked list. If
Yes.
there are two middle nodes, return the second middle node. 1, 2, 3, 4, 5. Second supposed to be 2, 3, 4, 5. If there are two middle nodes,
Give the second one.
the node was value and x, right? This is the whole thing, that node. So in that
You
case,
have to refer.
we have more than 3 actually. Here we have like the middle node of the list is not 3. I got you. Okay, the middle one. If, for example, there are 6, it's supposed to be 3 and 4, the both of the middle, but we need to return the number 4, second one. Okay. If 5, it's understandable, it's number 3. Okay.
Is it always supposed to be sorted or it's not supposed to be sorted?
It doesn't matter.
Doesn't matter.
The information inside is not important.
Is it possible to count the how many nodes we have it?
It's possible.
It's possible. It's we can. I guess we need to first of all create the count.
It's also possible.
And then we will have the how many nodes we have it, and then we will divide into 2. We will get the number. For example, if 6 divided by 2, gonna give us 3 actually, but we need no.
But that makes sense, like
Yeah,
0, 1, 2, 3.
Oh, the we can use modulo. No.
You can use whatever you want. I mean, like, how you do it is.
So
Yeah.
the main my idea is to find out that how many what's supposed
Elements
to be the middle.
are. Yeah.
Yes, and that middle will be our while, like while equals this, we're gonna stop. When we find no, it's not while. Actually, when we will find the correct node for us, I will return that number.
Exactly.
Yeah.
Remember that there are 2 things. When do we use a while and when do we use for each? That is something very important to know. When do you use a for each, and when do we use in this case a simple for loop? It's a question.
For each is not returning anything. You just modify all this like
That's our
the
idea.
initial.
We need to modify the output.
Not specific.
For each will.
No, sorry. A while. When do we use while, and when do we use in this case a for loop? I'm sorry, it was my mistake.
Nothing about for each.
No, nothing to do for each. It was my mistake.
Okay. Here we can use, by the way, for loop. I see. Yeah.
I mean, they're both same. You can do with both same things, but sometimes while is in some cases more easy in some cases. But the global idea do the same thing. You can do whatever you want with the both.
Yeah, but the difference is that one I know how many times I will do it, and the other one I don't know.
With while.
With while you don't know how many times you will do it, but with for loop you can say it, do it X amount of times.
Right.
Yes, that's why we need to find the middle first.
Exactly. You need to know how many elements do you have. That is the main.
That's why I'm saying we need to use for loop, but how to find that middle one?
That length divided by 2.
No, we cannot use that length. It's not the array, right?
I mean, we can do it to you. It's like a previous example. We can create an array with put the all value there, and then for loop it and divide it by 2 using the for loop.
No, if you will divide by 2, for example, in the first case, we have number 5. Let's say we are dividing by 2, it's gonna give us 2.5. But this 2.5 is supposed to be 3. And then, for example, in second example, we have 6.
You can use math floor.
Okay, but what if we have 6? 6 divided by 2 will give us number 3, not 4.
No, it's gonna be 3 point. Since we're counting from 0, it's gonna be 3.5. It's not gonna be 6. It's gonna be the 7. By the way,
if you do array that length, it will give you 6. No.
Does it?
Let me tell you something. If you are making 1, 2, 3, 4, 5, It
So
will divide it between two. It will be 2.5. If you go floor, it will give you 2. 0, 1, 2. If you go here and you get 6, and then you say the half is 3. 0, 1, 2, 3.
yeah, and we will use modulo.
As you like, my dear friend. It's not a problem. The solution is solution. Maybe I can even be completely wrong, but
The
after that, I
modulo will
will show.
give you, like, for example, it equals to 0, it equals to 1. It's gonna be your
No.
even or odd. In that case, you
Wait,
can understand.
one thing, sorry, one
Okay,
thing.
possible. Mhm.
Just Maksat make me a little bit confused. For example, if you have 6 values and we make it that length, it's gonna be counting from 0 to 6. So it's gonna be like, how many? It's gonna be 6, right? Or 7. Wait, I'm a little bit confused. 0 till 5. No, it's gonna be 6. Yeah, it's gonna. Okay. I just a little bit confused. Sorry.
Yeah, it's okay to be confused. The
And
idea
just
is to
sometimes
remove the confusion. That is
because
one
it's
solution.
Maybe we can just start one by one and
The idea, like, I am tired of coding. Would you mind to try to code yourself? A little bit. I'll go
let's
over
go.
there.
Maksat share your screen if you have it.
Yeah, send me please that link.
Yes, absolutely. There you have. And think about that you are in an interview and I am just check it. If you need some information, you don't know something, you can ask me. I will answer you. And when you finish, I will show you another way.
Let's imagine that we know which number we need first of all. Let's imagine that we know that it's supposed to be 3. So how we can do it?
Mm-hmm. I think like you need semicolon, not just comma. And the other one too. Yeah.
This one we will figure out later how we can find this number.
Oh, okay.
So we know that it's supposed to be 3 times.
Oh,
That our
okay.
head supposed to be 3 times.
Mm-hmm.
And then let's say we need to no. Let's say wait.
I think like this one has to be before the for loop.
Exactly.
Okay. Mm-hmm.
We created that one.
Mm-hmm.
And then how was it? I would forget.
Head copy equals to head copy dot next.
Wait. Head copy
Mm-hmm.
equals to head copy that next. It will go to the next one.
Next, no, next. Next.
This first one will be number 1. Then we'll go next one
Mm-hmm.
will be number 2. Last one will give us number 3.
Yeah, exactly.
Yes. And
The other one also has to return you the number 3. Okay, yeah.
yeah, I need to return this number.
Mm-hmm. Okay, then you just have to return the head copy, right?
Do I need to return the whole list or just number?
No, you have to return the whole list. Remember that is after the for loop.
Yeah. So I will put
Okay,
after
okay.
the whole loop finish it.
Okay.
This one's supposed to be.
Mm-hmm.
Now I need to understand how to get that number. I don't know
Okay.
this one.
Maybe you run it and you see what's going on right now. Would you mind to?
It's supposed to be give us correct case first, the others gonna be wrong, right?
I
I mean,
think
you have to
Give,
return
give me
the
5.
last one.
Because why?
Last one.
Huh?
Why
we'll
you-
check the second one.
I mean, what if you return the not head copy, but the head itself?
No, because you are not modified. If you return the head, it will be
Yeah.
completely.
All right. Four and five. Because
this one.
it starts from the three, right? I mean,
One.
wait.
1, 2, 3, 4.
I don't know. This one is correct, I think. Go up.
This one.
Is it?
Oh, it means it's supposed to be 0, 1,
Mhm.
2. Oh, it's 0, 0. It's 1,
Mm.
2, 1, 0, 1, 2. It's supposed to be finish when it's equal less than 2.
Mhm.
Yeah, we
Wait,
can do it like -1 later. Something like
One-
that.
Mhm.
One thing, why is starting from 0 till 2, but it's returning about last ones, not the first ones?
The last
Like
ones?
that.
Huh?
What do you mean last ones? This 3?
Yeah. If why is
Example,
it give you
for
2?
the first one, this index 0, will give us the
Mhm.
whole thing.
Mhm.
After the second index, will give us like this.
Mhm.
And third one, the 2, give us this one.
Okay, but why is it?
It's since it's linked list, for
Okay.
example, linked list, it looks like this. For example, first FL value is 1. Then next will be like
Object.
2,
Mhm.
and next
And then, okay.
3, 3, and so on. Like,
Mhm.
but I don't know why it shows like the array. I guess it's kind of
It's how it's represented. It's not other stuff, but
Yeah.
in reality, it's what Maxat is showing. That is how it is in the under the
Yeah,
hood.
I know how it's look like. I understand this one, but why is start like removing the first ones and give it to last ones?
I'm not removing actually. I'm just going to the next one. For example, look at this. Before, let me almost finished. It's supposed to be up like this, and then next. No. Okay, that now is
Mhm.
showing everything.
Mhm.
When we move to the, I said, head copy next. It
Mhm.
means he moved to over here.
Okay.
Actually, it existed, but since I changed my head copy here to hit copy next, I just this next. You see this next. I jumped to this,
Oh, I got it now. I see
but this
now.
next have all of these things.
I
And
see
then I
now.
say it again in the second loop. I said again next copy. He will go to this one. This
I
one
got
plus
it. I
this
got it.
one.
Okay.
So
Okay.
3, 4, 5 is gonna be our answer.
Mhm.
Uh
Now you need to copy. You need to count how many elements do you.
yes,
What
I
will
need
be this? These two Where do you get it, right? That is the,
It's
Mm,
supposed to be counter -1,
oh yeah, makes sense.
but we need to change that counter.
Молодец.
I don't know how to do it. How we can change that counter?
This, if you take in consideration what we did before, then you will just have an idea.
oh,
Okay.
what
let's-
if you now you can create the array which have all values from the head
Okay.
and then like that length minus time with that. I don't know, delete by 2 again. What we been talking about?
How was the counter copy equals to head? Then how was that recursion?
While counter copy.
Yeah.
While
Counter copy. What we are doing?
Counter that push
Counter dot push.
counter copy
Counter copy dot
that
val, right?
val. Yeah, and after that counter copy that next. So you have all the values.
So I have here numbers.
Yeah.
Then what I have to do? I have this one is
Mhm.
So
actually
now you have a length.
length.
The main thing you have the length of your head.
For example, now it will give us 5, right? It give
If you
us
put
5.
length, yes.
Yeah, if I put length, it give us 5. I need to find the 3 or 4 if it's 6. How can I do it?
Since it says, what if you do? Since if you start looking it from the end, can you see like examples? Look at it from the end. It's like -1 is gonna be 5, -2 is gonna be 4, and the first one is same thing, -2. Maybe you can do just that length -2. I'm not sure it's gonna
But
work
what if
with
we
the
have
whole.
like 20? Let's
Okay.
say 20 numbers.
Then it's not gonna work. I'm just looking for this example.
No, we just need to, yeah. For this example, it's gonna work. But for the, if you submit, it's not gonna work. Okay, let's do like this. What if we counter that length divide by 2, we'll get some number, right?
Yeah,
It's gonna be 2.5
2.5.
or
And when
3.
Which one is gonna give you math cell or math floor give us the greater one?
Cell give us 3.
Cell? Which one, Mario? Cell or floor?
Cell give us like
Floor will give you the lower.
down.
The
Yeah.
sail will give you the next one.
Okay, then math cell.
Okay.
Then put create the variable which gonna have like a math cell. Yeah, counter that length. Yeah,
This one
and put.
give us 3. What about this one?
So it's gonna be the same. It's supposed to be give us like 6
3.
divided by is gonna be 3.
But this one's supposed to be 4. That's why I need condition. Like this, I guess, you know.
Then
If
okay,
like
what if for
number
example, Mario, if for example 6 delete by 3, and we're using math floor, it's gonna be give us just 3, right?
Yes.
Then we can do it myself. For example, using the math floor +1 at the end. for both example, it's gonna be the for the first one is gonna be 3. For the next one, it's gonna
Okay.
be, for example, floor. At the end, we're just doing the +1.
Okay. Let's say,
Just put length.
okay,
Yeah,
nice
+1
floor.
at the end.
Huh?
Not -1. We remove the -1. Okay. And you return. Return. Okay. Both
No, I
4
just
and 5
like this. Because it's supposed to be -1 actually.
-1.
Yeah,
Oh wait, why it start working?
it's working.
Yeah. Without
No.
-1.
Yeah, because we put here -1, but since I just deleted +1,
Uh-huh.
it's give us actually 2 and 3.
Uh-huh.
2
Yes.
and 3. 2 and 3, but here where I'm putting indexes. That's why 2 and 3 is actually number 3 and number 4.
So if you submit it, does it gonna work?
Yep.
Oh,
Wow.
wow. Genius.
Wow.
Do you understand why it's working?
Yeah.
Let's say change to the index number. It's gonna be a matching. But memory is I
Is
like
it
that
It's
runtime, but
lower.
memory is very poor.
is it what you calling the small code, Mario?
Oh
In the beginning, you said
no.
it's gonna be the very small code. So you confused us.
Yeah.
I've been thinking all the time about like one for loop, which is inside gonna be one line of code.
Uh, how can I say it? Mm,
It's
okay.
bigger than
Let me just show you something different. Okay. Maybe that will make sense for you. I start that. Okay. Okay. There is one technique that this is very specific that is called a slow and fast. Let me go. What is the half or something? That is the main question. The half or something is if you walk 1 kilometer per hour, in how many hours you will run 10 kilometers? And if you walk 1 kilometer per hour, how many hours will take you to walk 10 kilometers?
10 hours.
Yeah, exactly. Now, if you walk 2 kilometers per hour, how many hours will take you?
Half.
The half. Okay, then that is the idea. There is one technique that is called slow and fast. Then you just do something like this, and you say let slow equal head, in this case, and then let's say let fast equal head. Okay, and you start walking. Let's say it that you will walk while slow exists and fast has next. Okay, then fast can continue. If fast can continue, we go over there. Then I just say, hey, you know, slow, you will be equal to slow, dot next. But fast, you will go at double time. Slow, dot next, dot next. because fast is going, so fast here, fast is going 2 times faster than slow. Then when fast is in the end, what will be slow?
In the middle.
In the middle.
Mm.
Then your return slow.
Oh my God. I will never do like even to think about it. I don't know. Next.
But if you make it makes sense, right? If I run it in this case, this has to
What
be
you did?
okay. Sorry.
I don't understand.
Sorry, here fast. Okay. Fast, slow next.
I don't get it, to be honest.
Oh,
Let
okay.
slow equals to head, let fast equals to head. The both of them head, right? And you're saying, while fast and fast
Exists. Next exists.
slow equals to slow dot next, fast next. Oh, it's the next one.
It's 2 times. It's 2 times faster. That means like this is moving 1 slot and this is moving two steps. Like this is going 1 kilometer per hour, 1 mile, and this is going 2 miles per hour. Then
Working, I don't get it still.
yeah, it's basically okay. Both start here. Both start here, right?
Okay.
Then you have slow and fast and starting here. In the first iteration, slow move 1.
Okay.
But fast moves 2.
2
1,
times.
2. Yeah,
Okay.
was here. The second time, slow move 1 and fast move 2. 1, 2 is at the end. Then I return slow.
Because you are putting while fast and fast next.
Exactly. Because I just
You
I
can
need
put
to
just
move.
only fast next, right? You don't need that fast and fast next. You just can only keep fast next.
Okay. I am not sure if because there will be a moment when
Oh, you don't
fast
have
will
fast. No, actually, you don't have fast next, right? Actually.
yeah.
Or-
I don't have fast next. If I have fast next, then I can go to next, right? That is why. And here I have both at the same time, both at the same time. Then slow 1, fast 2. 1, 2. Okay. Then slow 1, one more. And fast go 1, 2. 1, 2. Okay, it's here, right? Then slow move 1. Then slow goes here. And fast is here. Then fast will be fast 1. And then I don't have anything. Then I just stop over there because it will be fast next. It will be null. It doesn't exist. Then it's returning. And you go over there. Ta-da-da-da. There you have. Memory is also not that good. Even though I am not using many stuff, it's still the same memory. It's using a lot of memory when you are having, in this case, this information. And that is the idea. And this one is fast and slow technique that you can use it. And basically is when you need to imagine if you need to have the third time the third part of the linked list. How do you think you will do it?
You have what?
The third part.
The third part. Then it's gonna be slow next, and fast next.
Exactly. Exactly. It sounds funny, but that is the reality. I mean, this is just doing like this. If you go the double speed at 1, when the double speed arrive to the end, the slow speed will be in the middle.
Yeah, I get it.
And even you can find it here. Fast slow technique. What slow pointers? Fast is slow pattern. Okay. This is Floyd slow and fast pointer approach is called. Even has a name. And
Almost
this
like
is
2 pointers in linked list.
yeah, you can say like that. And this is what is happening. Look, you have here, and one is jumping two, and the other one, and this one it will be this circle detection. There is another exercise that okay, if you get it will be it's this one that is also using this similar approach. And it's called linked list circle. Okay.
To the second. Pause 1.
Here is the exercise.
Can we have a break before this one?
Oh yeah, absolutely. Why do you need a break? You are a developer. You don't have rest.
No.
No, I'm just joking. Let's have some time. That's okay. Okay, let's have some time and we'll return. Calm. Yeah.
Okay.
Let's okay. Because I am not giving any. Let's take 15 minutes. We drink tea and we are in peace over there.
Thank you.
Yeah, not to you.